Our next talk will be given by Piotr Staniów, a passionate software engineer with backgrounds in JavaScript, C++, and Python. And today he will talk about Redux Architecture, what he believes is a hidden gem of front-end development, and an architectural concept of organizing application state originating from JavaScript, but today maybe we will learn how to use it also in other languages. So please give a warm welcome to Piotr Staniów.
Hi, my name is Piotr, and as you might have already noticed, I'm not a rock star, but I'm a passionate programmer. And today, here on this stage, I'd like to share my passion with you and tell you quite a few words about Redux Architecture. And as it was said, it originates in JavaScript world. It was invented by Dan Abramov in Facebook and announced around 2015. And it was a variation of other architectural concept called Flux. Flux architecture is the underlying concept in Facebook application. Use it on a daily basis without being aware of this. And Redux is also used by Facebook in some of their projects. But the main app probably with the largest market share could be possibly Instagram. And what I would like to show you today is that the concept is, well, kind of easy. We'll implement a simple library with, say, about 50 lines of code that you can implement in any programming language you would like to. It will be easier if the programming language had first all the functions. So it may be a C++, it may be Java, it might be JavaScript, Go, Python, whatever you would like to use. Let me go quickly through agenda. So I will tell you a little bit about what is an application state. I would like to have a common understanding of this concept. I would like you to think about application state the way I think about this. And this will be crucial during the speech about Redux. I will also tell you about what Redux actually is, what you can do with that, why to use it, and when not to use it, and how to align your application to use Redux. It can be any existing project. Then I will implement live here in front of you this basic implementation of what is called Redux Store. And it will have most of the feature the library has, and you could also implement it in your projects. During that time, you'll have an opportunity to ask me any questions. When I'm writing code, please feel free to ask me questions. I can explain if something's unclear. And at the end of the presentation, I'll show you a link to this presentation, how to contact me if you had any further questions, and we'll have a short Q&A session. So what Redux actually is. So when I say Redux architecture, the first thing that comes to my mind is that it is an architectural concept. So two things about this. First, it is about architecture. So it is about organizing your life. You basically, probably most of you, spend third of your day, third of your life programming. And the way you are writing your code is a way how you organize third of your life. So why not to pay attention to this? Why not to put some constraints? Why not to put some limitations, ways of thinking that will help you speed up the process of development on a large scale? And second thing, it is a concept. You may have some deviations. You may change it slightly to better suit your needs. However, the concepts that will be presented here are rather a one unit that should be used as a whole. It will best serve you when used as a whole, but pick whatever you need. And another thing is that quite a few of you might be actually familiar with a similar concept of definite finite automaton. DFA or state machines are relatively similar to this concept. Some of you may actually feel this rings a bell. You've seen it somewhere. Maybe you've used it. But here it is proposed again as Redux. So maybe the differences will be beneficial for you. One thing, it is a lightweight, reliable, scalable application architecture. So it is a tried and tested technology, and lots of large-scale applications are using this. To name two of them, it's Facebook, it's Instagram, but also other companies do use Redux. And some of those also use Flux, that is the first concept that lied as an inspiration to Redux. It is also, as will be shown later on, a small set of building blocks that you may use to manage your application state. What I mean by this is you'll have some utils that help you build your app. And those are relatively simple, and you can reuse them. And it is also a way of thinking where to put business logic. As is the case with MVC, Model View Control Architecture, it is also about where to put logic, where to put things that belong to each other. And here it's, well, kind of similar, but still different from MVC. What is an application state? When I discuss the application state, I mean state of whole application, no matter how large it is. And most probably, you would like to use Redux when you're dealing with a large application. You'll see later on that it builds up some boilerplate code that may feel a bit repetitive at the beginning. But I also may tell you that in large applications, you'll feel later on that 80% of the code you write is a copy-paste and slightly change when using Redux, and only 20% is like something new that you have to reinvent. And the thing is that because of that large boilerplate and because of some mental threshold your team has to pass, Redux should not be overused. You may for sure use it in a small project when you're learning, but you may not feel the benefits of it if it doesn't scale, if it is not needed to be scaling. Application state is all the information, all the data that an application needs at any given moment. This might be user responses. So in web applications, this is natural because you're communicating with some databases, you're communicating with some APIs, and you have to store the information you gather. And this is a piece of application state. But also it is user input. And it is quite common for applications that are running on our computers to ask user for some feedback, for some input. And this is also your application state. You have to keep this data stored for later usage. It might be also sensors feedback. When you're developing an IoT application that will manage your things, that will manage whatever you connect to the master device, they all have some feedback. You might have a temperature controller. You may have a GPS locator. You may have a humidity sensor. They all may need to send some data. And the data you receive from those, or the information you'd like to send them later on, is also application state. It is also about persistent data. Sometimes you need to persist some settings. Sometimes you need to persist some information that will be used later on. For instance, authentication tokens, information about when to turn some sensor on, when to turn user's lamp on in a room. And also, application state is about displayable information, so about your application UI. You may want to give a proper content and structure to your information to display it in a user-friendly manner, and all the information that you need to put here to expose to user, you probably have to store them somewhere. And as such, all the informations I've mentioned, all the information your apps need at any given moment, those are application state. So there is one thing to rule them all, and those are three principles of Redux. And now I'm saying something contradictory also, that these are the intents of Redux. Because you may feel that some of these principles don't belong to you, that you don't want to follow those. I'm saying that's okay, you won't have Redux, but you still may have some benefits from that. And so the first principle is that an application that follows Redux architecture will have a single source of truth. And it sounds kind of religious, doesn't it? It's a weird thing. But that's the simple statement that tells you that all the information you need for your app, that your application state will be stored in a single object. And also this is why I state that this concept might sound a bit familiar, that you have some finite automaton that steers your application. But there will be some other constraints. There will be some other building blocks that we'll use. But my suggestion is to start organizing features in your application, to start organizing your applications the way that all the information you need is stored in one place. And first what may come to your mind is, but I will have a giant object. Yes, you will, but you have this information in application either way. You just have it stored all over the application in various variables. You sometimes have some boilerplate from data structures that hold that data, so why not put this all in one place? And to use some techniques to just take the piece of information you'd like to have. And the second thing is, let's make this state of application, let's make this object a read-only one. Let's not allow any part of the application to mutate it. Because one of the most difficult things about programming in any programming language is that you don't know what your code does, right? And no matter if you develop for a year, whether you develop for 5, 10 years, or 20, most of programmers, regardless of the experience, say that it happens to them again and again, that they don't understand why something is not working. And sometimes they don't understand why something started to work. And I'm telling you that read-only state won't fix that problem, but it may help you, because you'd be able to track easily where the state was changed. Because the updates of the state will be handled by Redux tools. And because of that, you'll be able to trace when the particular functions of Redux store were called, when the mutation of your state occurred. And you will be able to reason about what is happening in your application. And third principle, state is updated with pure functions, namely reducers. What I mean by this, it is a programming concept that is widely known in functional programming languages, is that a function should not have side effects. That is, it is kind of a mathematical concept that a function only accepts some arguments, and on given arguments it always returns the same output. And it's not changing anything outside. It's like mathematical sinus function, right? When you put 17 to sinus, you expect always the same value to be returned, and you expect the mathematical function not to change anything around, not to change your global variables, not to change any services, not to touch them. It's just put something in and expect always the same output. And this is something that simplifies reasoning about what happens in your app, because you'll always be able to track what was the input to the reducer and what was its output. You'll always know how did you get to a given state. And this chart here, it tells you a little bit about Redux Flow, how it's organized, how your application could interact with any actors. And by actors over there, I mean not only users. I mean your sensors, your antennas, your devices connected to your system. Basically anything that may change your application state, that is a source of information in your app. And when any given actor interacts with your system, that is described by this circle, it usually interacts with some components. And those might be considered, don't have to, but might be considered a UI. It's like one way of thinking about this, a simple one, that you have some UI and the user is inputting something in your components. But on the other hand, you might have some components, sort of components controllers to your sensors. And whenever any interaction happens to this system, an action is dispatched. What does it mean to dispatch an action? Well, first of all, an action is just a simple object, event-like, that tells what has happened in your app. That you've just received an information that temperature has changed, that user has put something on your form on the website. And it consists of information, what has happened, and also a tiny little bit of information needed to process the information. So when you receive the feedback from temperature sensor, you probably would like to also inform what's the new temperature. You would like to make a use of it, right? And as such, the action goes to reducers. Reducers? Well, Redux has plenty of kind of new names, but Redux is simply a function. It is a function that accepts a state, a current state of your app, and an action, and it returns a brand new state. And it would be best for your reducers not to mutate this state, but to create a new one based on the old one. And you may think, how is it? I have a giant data structure, and you tell me to copy this? Yeah, use a shallow copy. Well, such a data structure may be considered a tree, and because of that, you're changing just one path in this application state with any given action. So the overhead of that is small, but detecting that your application state has changed is cheap one. It's over one. It's constant time. And reducers, they do produce a new state. So the new state is produced during the reduction and is stored. Well, the whole circle here represents also what we will program later on. It is a concept called store. It is a class that holds all your goods in one place. It has ownership over your state, and as such it is responsible in a manner for keeping the updated state. And then you have updated your application state, you have stored the information you need. So it's time to inform any parties that are interested in these changes. So this is a notification part. And, well, it's handled in a variety of ways. So if you're a web developer, and if you happen to use React, you probably would use Context API to get these updates. If you happen to use Angular, then you would use RxJS, so observables, to get the updates. But what I'm saying is that if you're not a web developer, you also may have all of those. It's just classes, functions, hash maps, and here you'd have some pub/sub pattern, publisher, subscriber. So as you may see later on, it will be handy to be able to pass function as a parameter here, but it's not required. And then the components that are notified about the updates may also give the feedback somewhere else. So, for instance, if you have a thermometer in your living room and it sends information to your app that the temperature has changed, you may want to push that information to another device like bedside lamp that turns on when the temperature is below or above some threshold. And here comes the moment. You probably expect most of the presentations during Code Dive to be in C++. I think this is what happens in most cases. But today, I have picked JavaScript on purpose, not only because I write mostly in JavaScript during recent days, but also because I want you to think about how will I implement this in my favorite programming language. I want you to focus on that and start thinking, how would you code that? And ideally, when you get back home, try and implement this and start using it in your apps. So here is a simple beginning. We have some almost empty web page that has a list, an input, a button, and it represents the agent that is interacting with your system. And to the right, we have a store. And this is the main part of any Redux library. It has some means of maintaining your store. One question is, are you all able to see clearly the code? Should I enlarge it? All's fine? Great. Okay, so I'll try to make lots of mistakes, produce lots of errors and warnings, and let's hope something will appear. So that's our app. We have a list of to-dos. Seems like a trivial one, and we have a point of interaction. I'm the agent to the system, and I would like to put a to-do here, like do laundry, and to add this to the list. Maybe in the background it would be sent to a server, maybe it would trigger the washing machine, but that's the target, that's the goal. Let's focus on this part. So I've told you that store is a class that has ownership over state, which is a hash map, a large data structure, potentially large one. And it also needs some information about reducers, because reducers are the functions that will have business logic in your app. And we need to keep some information, some track of them. So let me begin with saying that we have some initial state and reducers. And we'd like to store them. That was an easy one. We may also say that if user is not providing us those, they are simply empty hash maps. Okay, that was an easy one. Next, I'd like to be able to dispatch an action. I'd like to say that something has happened in my app. So because of that, I'll write a dispatch method here. And it accepts an action. And what it has to do is to actually call your business logic and to update your state. Okay, so let's go through keys of the hash map. And let's take those functions that we use. Reducer, reducer's map is basically a map from name of reducer to the function. What we also would like to do is to say that we are creating a brand new state. So the new state is a shallow copy of our current application state. And because of that, let's take a piece of that state. Let's update the state piece by piece. And the partial state looks like that. Okay, that was a pretty easy one. So let's call the reducer with the partial state and an action. As I told you, reducer is simply a function that takes a piece of state and an action, and it returns the updated piece of state. Okay, and because of that, let's finally assign this state to be the new one. Okay, and to see some interaction, I probably need to write a little bit more code. But I would say it's like 50% of the library that we are writing today. And we'll write some more code just for debugging purposes so that you can see clearly what's happening. Okay, so whenever this function is called, let's see what's the current application state, what's the action, and what's the new state. So this state represents our current application state. We also want to see what is the event that is happening. And we'd like also to see what was the result of using reducers. Okay, and another thing is that we probably need some action to be dispatched. So, as I said, it is a simple event object that has some type. Well, type is a string. So let's start with a dummy action. And let's use store.dispatch to actually dispatch this action. So that's the initial part, and let's see if it works. Maybe it does. So what you can see here is that we have some previous state. It was initialized as an empty object, as an empty hash map. There is an action type dummy that is being dispatched. And well, the next state is still an empty object because, well, nothing's changed. We don't have reducers. Okay, so let's have some more meaningful states, and let's have a reducer. So our ToDo reducer is a function of ToDo state and an action. And one of the ways to check what's the type of the action is to use switch statement. Well, it works pretty well if you don't want to have multiple if statements. So if we don't recognize the action being dispatched, just simply return the state. Nothing's changing, the reference is still the same, and we are not changing anything. But if it's something that we'd like to handle, like add ToDo, we can do something with that. But for this, we may first think about what is the ToDo state. Well, ToDo state, it is nested in our giant hash map, and it might be another hash map with ToDo state, right? So the initial ToDo state can be also a hash map. It may have IDs that are an array, and some entities. Again, a hash map from IDs to ToDos that will handle the information. And one thing that is unspoken here, you may think, why so complex? Why not just a simple array of ToDos? Well, one of the things is that in large applications, like quite large ones, you would like to normalize your state. You would like to process it a little bit like a database. And because of that, it's handy to use this IDs entities separation and to refer to entities, to, for instance, ToDos by their IDs. So when you have an idea of a ToDo, getting it from hash map is, well, simple. Okay, so when I receive a new ToDo that would like to add, I need to return a new piece of state. And the IDs will be copied. And I'm adding a brand new ID. Let's say that an action will carry information about the to-do being added. And that's the ID I'm adding here. Entities. Again, we want to copy anything that is unchanged and add a key to-do ID that will equal to-do. Okay, I've just added a brand new to-do. And we are not using the initial to-do state yet. So let's say if the state was undefined, we want initial to-do state. Okay, let's move the creation of store somewhere down below. So the initial state may be still an empty object, and we may need to say what are our reducers. So we have a to-do reducer. And let's actually pass it. And for this to be meaningful, well, we'd like to see it works, right? So let's dispatch an action that actually says, I have a brand new to-do. Add me this one. And again, this is a simple hash map. It has information about type of event that is happening. And it may have some additional information, usually called payload, but it's not required really. And I'm telling that to-do has some ID. And it may have some description, like walk your dog. And we may want to dispatch that action. Let's see what happens. Maybe it compiles. Well, it does. That's a good one. So first, I have dispatched a dummy action. So we started with an empty object as an initial state of our whole application. The action that was dispatched was of type dummy, but all the reducers were called. And as such, it resulted in updating state. Because we have to-do's reducer that returns some initial state, right? So hence the to-do's key. But it is in fact an empty state, right? We have an empty list of IDs and we have an empty hash map of the entities. But then the magic happens. We have this state updated, and here comes the new action with your brand new to-do from your agent. And it updates the state. And here you can see what is the data structure, right? So entities, it is a hash map from, I need to probably move this around a bit. So you have this entities data structure, this entities hash map over there. That is a hash map from an ID to the actual object. And you have also this list of handles, this list of IDs that will be used to refer to those kind of references. Okay, so one thing that we are probably missing from the initial chart is the notification part, because we have some dispatching, we have reducers that change our state, the new state is updated, we install, and we are not notifying the UI that something has to be changed yet. for this, we need probably some publisher-subscriber pattern to be implemented. Let's go the easy way. Let's have a list of observers and two functions. Add observer. It will basically add this observer. And we don't want memory leaks, probably. So let's return an unsubscribe function. All it does, it's a lambda expression. All it does, it reassigns observers to not include the just added function. And we have the possibility to add an observer. What is an observer? Sorry? Well, yeah, it is just a function. Just simple as that. And we'd like to notify all the observers that a new state is present. So whenever we change the state, and the only place where it occurs is this dispatch action, right? So as I've told you, your applications may rely on a simple one, quite large, object in your app. And the only place it's changed is this dispatch method. And it's powerful. Because no matter how large your application is, it may have 50,000 classes and components, and may still rely on the simple fact that always this state is changed only in dispatch. And the notification part also goes here. Okay, that being said, we have 75 lines of code, and this is a working library. And I'll show you how to use it actually, because we don't have that part, and it will grow to around 100 lines of code. But you've just seen the implementation of what can power application that is scalable, that is testable. Okay, so now the using part. We have this add ToDo button that whenever it's clicked should dispatch an action. Thank you. And we need to add an event listener. When it's clicked, let's create an action. And again, action is just a simple object, a simple hash map, and it will have some information about the ToDo that is being created. We also need to keep track of what's the latest ID of the ToDo. So let me do this like that. Well, simple yet where I can. So the ID will be ToDo and the last ID updated. And now we also need to get the information from the input. So the input is here. It is a new ToDo ID. and we can simply grab its value. And finally, we need to dispatch this action to update the store. So we have a list of to-dos. So one thing is that the action is emitted. That's a good one. Second, it has all the information needed. And final, it is updated. I should probably start numerating this from 2, because we have that fixed to do 1, walk your dog. Okay, so that's the part of how to use it actually. And again, this is a very simple and very powerful thing that you, whenever anything happens in your app that you need to handle, that gives you any information, it's just a matter of simply creating a hash map with 2 keys, a piece of information that needs to be processed, and the name of the event. So it's not really a new concept. It has at least 30 years. But it's put down here into a group of practices, into a group of constraints that are tried and tested and work well in any environment. And the last part is that we'd like to see it working, and that we'd like to be notified about what has happened. So let's create an observer that will take the list Let's erase its contents. Because simply whenever you receive a new to-do, you would like to re-render those. You would like to get this from scratch. It's suboptimal. You may not need to remove all of those, but let's do this for the sake of simplicity. And let's create a new item on this list. So we are receiving a new state here, and it has a list of to-dos. We can go through the IDs. There are sufficient information about how many IDs we have, how many to-dos we have, and they represent them uniquely. And for each such ID, we would like to create an item. Put some description in there. And add it to the list. And this observer needs to be registered. And here is the first action. I've registered the observer after dispatching the first action. That was for the debug purposes. The walk your dog action. So it was dispatched and the state was changed before I registered the observer, and it started to notify our UI only after it was registered. So hence the 2 items here. So it's just a matter of reorganizing your code if you want to have all of those displayed. Yeah, it's a duplicated ID. I've started with, let's see what happens now. it's now working fine. I had a collision of ideas, right? And, well, that was the live programming session. Wasn't that bad. It wasn't ideal. We had quite a few errors and issues. But the concept is as simple as that. You have 105 lines of code, and this is a working library, and you could publish it if it wasn't already written as Redux. So it's written in JavaScript, but as I told you, because the concept is so basic and it's just about discipline, about organizing your application and organizing your life, your third of your lifetime in this manner, you could write this in any programming language you'd like to. I hope you haven't noticed there anything that is absent in Java or C++ or any other programming language. You may need to, well, change things a bit if you use some lower level language or something with an older standard. But that's the concept that you may introduce. Thank you for your attention. I hope you liked it.
We have roughly 6 minutes, so I assume you're open for some Q&As.
Yep.
Whoever has a question is asked to raise a hand. I can see the hand in the back.
Thank you. Well, I have some experience with some old-school web applications like Django and so on, where everything was server-side. And now I see that it actually maps quite well to what you said. Like the HTTP request would be actions, and we have a dispatcher inside the Django, and so on, so on. And all the state was in the database, so also in, everything in one place. But now I'm thinking, if the state is already on the server, and we have something like, well, something like a Redux architecture on the side of the server, and now we have single-page web applications which have also this Redux architecture inside with its own state. How do you communicate states between those two parts? Because you can't just send everything from the database to the user, because firstly you cannot, because there's the idea of other users, so you could also only send some subsets only. And even this subset could be just too large for a JavaScript application.
Yeah. So basically, as you said, you cannot expose the state of your backend to a frontend. So that's first thing. So it's it would be a security concern. So definitely, I wouldn't do this way. But you can take different approaches. One would be to treat those as two separate applications, a backend and a frontend. And I believe, like, you can argue with that, but this is an idea that is getting some traction nowadays. You have guys that are telling you that you should have mono repo and everything is one app, and you have guys that are telling you, well, let's keep everything separated, let's keep micro frontends, micro services. And, well, one approach to this would be to treat those separate and to just exchange the information that you need to exchange. And another thing that could be going well is you may use GraphQL technology. It's a bit like REST, but it's an alternative for REST APIs. It exposes basically all sources of data as one endpoint, and you could then try, for instance, to store your front-end app state on the back-end side, if you needed that, right? Because you don't always necessarily want to let backend know about everything that is happening on the front-end side, but you can do this, definitely.
Thank you.